Hello. Hi. I think we got 6 people in the room, so maybe wait a little bit. My name is Yang Hao Lin. I'm a principal system engineer for Cambium Networks. My focus is in PTP system, PTP 820 system design, and help customer do the troubleshooting. I did a lot of PTP 820 deployment. So today I'm going to talk about a few things on how to what's the on the topic of PTP 820 deployment best practice, deployment and design best practice. I will show you a few features that can help you improve the spectrum efficiency. So the two features that you can use to improve the spectrum efficiency is 4x4 line of sight MIMO, and the other feature is AFR, Advanced Frequency Reuse. And then I'm also going to talk about some best practice in the PTP 820. What do you need to know? Something that's not easily, something that you cannot easily spot from the user guide. And with 2+0 configuration, solutions for 1+1 hot standby configuration. So 4x4 MIMO. So here's the thing. Suppose you cannot get enough RF resource. Oh, sorry. I'm sorry. The looks like the slide is not showing on the screen. Now you should be able to see. So actually, I was trying to page up. Yeah, I was trying to show. I was trying to show this. Okay, so good. Two features for spectrum efficiency improvement. One is 4x4 MIMO, and the other one is AFR, Advanced Frequency Reuse. So when do you need to use 4x4 MIMO? Suppose you are losing, you need to have a lot of capacity in your backhaul, and you either want to save money in certain scenario, if the IF license is very expensive, or you actually try to use a frequency, but I mean you're running out of IF resource. So what do you do? So you can use 4x4 MIMO. So with 4x4 MIMO, you can quadruple the RF efficiency. Suppose you use one channel, and with 1+0, you can only get 250 megabits per second of capacity, for example. And so with 4x4 MIMO, this same channel, you can achieve 1 gigabit capacity. So just using the same channel. So you quadruple the RF efficiency. And the way to do it is to use antenna separation to achieve uncorrelated receiver string. So basically, we use the antenna space separation. We can form different phase of the IF signal. So at each side, the data is split into 4 big string. So you will have 2 antennas, and you can see that we actually, from this picture, you can see that there's 2 string, but this 2 string is actually each string is actually 2 string again, so it's 4. So each radio port is actually giving out 2 strings with each radio is giving out 2 strings. So you get cross polarization. So X peak, you get X peak, and then on top of X peak, you use the phase separation to achieve a double on top of X peak. So X peak give you 2 times the capacity, and so with a phase separation, you have you double again. So the receiver is able to distinguish between the strings due to the phase difference caused by the antenna separation. So let's look at how it looks like. So you can see at each side you will have 2 A20C radios, and each attached to a antenna. So you see that the A20C radio with the antenna, they are actually separated with a space of like H. So we saw H1 and H2. And actually you can use a formula to calculate how much separation you need. So you see the first radio actually is beaming out 2 string, V pole and H pole. That's using X peak. And again, the second radio link also another X peak. But then to X peak, using phase separation, you achieve 4x4 MIMO. The installation is a simple direct mount installation. So here we saw the formula to achieve the separation. You can see the H1. So here, sorry, H1 is here. The separation here, H2 is here. So you can see the way to calculate the separation is, you can see, if let's say assuming that you have both side and both side, they are equally separated. So you can say H optimal square equals to D times C divided by 2 times F. So D stands for the distance of the link in meters, and C is the speed of light, and F is the frequency, the RF frequency. So this will give you the optimal separation space you need to achieve the highest modulation mode. The chart on the right hand side show you, depending on the link distance and the radio frequency, the band that you are operating on, what would be the optimal separation. So one would say, okay, if I want to achieve optimal separation to get highest modulation mode possible, for a 6 gigahertz link of, like, say 10 miles distance, I would need more than 60 feet. That's a lot, right? So you say maybe I cannot find the tower space that allow me to achieve such a separation. So, but the thing is that you don't have to have this optimal separation. You don't have to have perfect separation. What you need to do is, you can look at this on the left hand side. You can see this chart. If you are only like a 50% optimal, you can still achieve 70% of the capacity. So basically, it's very flexible. It's pretty low sensitive to antenna installation. So you don't have to have perfect separation. You can have some separation, but you still can achieve a goal to increase your capacity. But obviously, a higher frequency link would be more easier to plan for 4x4 MIMO. The other feature for so you see with the 4x4 MIMO, we're talking about point-to-point link. So on a point-to-point backhaul link, if you want to quadruple your capacity, you use 4x4 MIMO. But let's say, what if you're planning a hub site with multiple remote site? So what can you do to increase your capacity? You will be dealing with, let's say, if you want to increase your capacity, and if you are running short of RF resource, what do you do? Sometimes you have to densify the area. For example, initially you may have two link, I mean, from a hub site, but then maybe you will have to add more remote sites. So the densification challenge, and then again, you may be running out of spectrum to use. So what do you do? So for example, let's say you are required to plan for a hub site with 4 remote sites, and you require very high capacity. For example, a gigabit per second or half a gigabit per second to each remote location. One way to do it is, I mean, you can easily say, okay, I'm just going to apply for 4 frequencies, and then I set up 4 link. This is assuming that you really can get that 4 frequency. What if you cannot get 4 frequency? Instead, you can only like get 2. What do you do? So here's the way. So we introduce the AFR feature, Advanced Frequency Reuse. With this AFR feature, you can see from this picture, with a very small angular separation, you can share the same frequency. So now instead of using 4 frequency channels, you only need to use 2 frequency, and your angular separation is only 15 degree. If you want to achieve like full capacity using the same frequency, usually you will need to have a 90 to 120 degree separation for interference free and full capacity. But with the AFR, you only need you only need 15 degree or more. So you can see, with this feature, you can add more sites in a small area, in a very low angular separation. So you use AFR to for frequency reuse, okay? But let's say, what if you want to double the capacity? You have the RF frequency already, but you want to double the capacity. What do? You can actually combine the 2 adjacent channel together to form a bigger channel. And because with the AFR, that channel can be reused. So you can actually bundle 2 frequency into one and do the reuse. So basically, you double the channel size and you double the capacity. So with AFR configuration, we support 2 configuration. One configuration is called AFR 1+0, which is already available. So with AFR, you will with AFR 1+0, you will, at the aggregation side, you will have one multi-core unit at the aggregation side. For example, A20C dual core A20C at the aggregation side, and then you will have 2 A20S single core at the remote side, or we call it tail side. So that's for 1+0, but we're going to also support the configuration for 2+0 XPEAK with AFR. That means at the hub side, you're going to have two 820C or any dual core radios. And then at the remote side, you are going to have one 820C. So you can see that with AFR 2.0, the link to each remote side is actually XPIC link. Okay. So with XPIC link, again, you double the capacity, right? And this chart shows the benefit of enabling AFR compared to not enabling the AFR. You can see, let's say take a class 4 and ETSI class 4 antenna, for example. So you can see when you enable AFR at a 15-degree angular separation, the co-channel interference is reduced by 30 dB. So that's the idea. With the AFR frequency reuse, you actually reduce the co-channel interference, of course, and you can achieve high modulation mode. So that's the AFR. So these are the two ways for frequency, making your frequency reuse more efficient. And so things you need to know about PTP 820 implementation. There's a few tricks you want to know. So we talk about when we say with 820 we support 2+0. So what does 2+0 mean? 2+0 we say we support ACAP and ACCP. ACAP stands for adjacent channel alternate polarization. And ACCP stands for adjacent channel copolarization. So you see AC, we say it's adjacent channel. So what it means is that when you try to deploy 2+0 link using the same antenna, you want to use adjacent channel. Or basically we say you need to use the channel in the same subband. So let's take a look at this slide here. So I give you an example. Let's say we have different PTP 820C product operating in the 6 gig low frequency. And let's say if you want to choose 5974 and 6226, so that's operating in the subband of CH1W4, and basically this is channel 2. So you can see that, and let's say you try to choose another channel 6123 and 6375. These two channels cannot work together because they are not in the same subband. So you cannot let's say if you want to set down a 2+2 or whatever using the same, using a shared antenna, this will not work. So what do? You need to make sure that the radios are operating in the same subband. You need to make sure that the frequency that you're choosing will be in the same subband. For example, channel 3 and channel 3 and channel 6 will work together because you can use CH3W6, right? CH3W6, and the channel 5 and channel 3 can also work together. Or otherwise, you choose channel 1, channel 2, they will work together. So the point is that you need to make sure that the radios are going to be operating in the same subband. Okay, it's very important. Some customer buy the radio and then they put it on the tower and they get a lot of interference and they do not know what's going on. could be a reason. There's a self interference, caused by improper design because you did not follow this rule. So make sure that the ODU need to be operating in the same subband. You need to use the link planner to choose the proper OTU port number. And so the other thing is that for XPeak or cross polarization configuration, some customer very often they forgot to remove a rectangular adapter from the antenna. So inside the antenna, there usually comes with a rectangular adapter, and that rectangular adapter make it so that the antenna is only allowing one polarization. So you need to remove that because XPeak is dual pole. So you need to remove that and then replace it with a circular OMT adapter. With a circular OMT adapter, you will allow two polarization, two beams. Some customer they made the mistake and forgot to remove the rectangular adapter, and they put it up and they did the alignment, everything, and so when they try to look at the radio to see what is the signal strength, they will always see that, okay, I can only see one pole have signal and the other pole does not have signal. And they say, okay, maybe there's a hardware issue with the A20, the radio that they bought. But when they put it down to the lab and then cable them up, both ports are working fine. The change is that they forgot to remove the rectangular adapter from the antenna, and so only one polarization of the signal was passed through. Okay, and one other trick to use for your XPeak installation is, if you follow the user guide, people will say, okay, let's I don't know, I think maybe the user guide has updated, but read the user guide, and many people, many experienced installer, they will try to rotate the antenna and to a point that they say, okay, I'm going to get a XPI number that's optimal, and they spend a lot of effort. But there's an easier way, that is to use a label, just use a label, a carpenter's label, with a bubble. So basically what you do is you would put the label on the OMT. It's a flat surface. Put the label on the OMT, on the flat surface of the OMT, and then you rotate the antenna. So you will see that the bubble will be floating, back and forth until the bubble is at the center, of that, zone line, and there you know that it's the X peak alignment, polarization alignment is optimal. This turned out to be always work. I got a call from one of the customer, and he having trouble getting the X peak to work right. I said, okay, just go buy a label and then use it for your cross pole alignment. And he did it, and it's actually pretty quick. It's very quick. Okay, so let's say if you want to do troubleshooting of your X peak link, for example, you want to make sure that you get enough signal strength. The signal ISL is aligned with what the link planner predicted. What you need to do is you need to do single pole. You need to mute one of the pole, because if you don't mute one of the pole, that number that you're reading is not accurate, because the other pole will be also shooting the signal to the to each, to both port, to the ports that you're looking at, so you may get higher signal, and that's not what the link planner is predicting. So you want to mute one of the port. Okay. And one other thing to pay attention to is with the A20 CNS 2+0, some customer will want to use external switch to achieve link aggregation using link aggregation group, running link aggregation group from the external switch. So in that case, you need to be careful not to mix the media type. For example, you don't want to mix fiber port with copper. You may want to use all copper or all fiber, because I know many switches don't allow link aggregation group or ether channel across different media type. Some switch does, but you need to be very careful unless you are very sure. Okay. Okay, so about the 80 megahertz channel support, there's something you need to know. When you try to configure 80 megahertz channel, both ports need to be 80 megahertz channel. For A20C, both ports you need to configure with 80 megahertz channel. You cannot have one port running 80 megahertz and another port running like 60 megahertz. This is a limitation, so you need to pay attention to. Okay, and also keep in mind that with 80 megahertz channel, you cannot turn on MCABC, because one of the big reasons is that there's a limitation of the 1 gigabits per second with MCABC. So let's say if you're running 80 megahertz, and then so you run 2 plus 0, you will get more than 1 gig usually. And with MCABC, you are limited to 1 gig. So 80 megahertz channel, you don't want to operate with MCABC. And also, we don't support MIMO with 80 megahertz that we talk about. And a few things about the 1+1 configuration. So we support multiple options for 1+1 hot standby configuration. And so I'm going to talk about, so what's the difference between a splitter and coupler? So with 1+1, you need to use a coupler. Okay. So, and then when you do 1+1, the hardware should have the same part number. For example, let's say if you're setting up a A20S 1+1 hot standby, you need to use the same part number. If they are different part number, the radio will always complain, configuration mismatch or something like that. So it will never work. Same thing, software need to be installed on the same version. So with the 1+1 hot standby, make sure that same part number and same software version, and use coupler. You can use splitter, but why do you want to use coupler? The reason is that splitter is symmetrical in the loss. So for example, a splitter will lose 3.5 dB on the on both sides, but a coupler will have a loss of 1.5 dB on one side, on the main side, and 6 dB loss on the standby side. So you can see if you use a splitter, your best case scenario for the loss is 7 dB. But with the coupler, your best case scenario loss is 3 dB. So you actually, in the sunny day, if you're operating on the active unit, you are running at 4 dB better than using a splitter. Of course, I mean, when you fail over to the standby, you may end up losing like 6 times 2, like 12 dB, right? But that's very short duration. So majority of the time, you're going to get much better link budget. Okay. So that's what you need to pay attention to for the 1+1 hot standby configuration. And with the 1+1 hot standby configuration, we now support 2 modes. There's a split protection mode And also there's a line protection mode. So split protection mode work only with fiber. I'm going to show you later. And the line protection mode work with fiber or copper. Okay. So with the 1+1 hot standby protection split mode, you can see you will use optical splitter. So basically the optical port goes, they are combined, the two units, the optical port, they are combined by a wide fiber cable and deliver one single optical cable to the user device. Okay. And you can see that here you use a coupler to combine the radio ports, and the of course you want to use the main side for the active unit and the standby the standby side for the of the coupler for the standby unit. Okay, so that's the 1+1 hot standby protection mode with split protection mode. And also we support line protection mode. With line protection mode, we support both copper and fiber. So you can use the PoE port and use a copper, Ethernet cable. So with that, the way it works is that we rely on an external switch to help with routing the traffic properly to the active unit. So you need to configure LACP on the external switch. Make sure that when you want to use line protection or when you want to use copper, you need to make sure that the external switch will support LACP, Link Aggregation Control Protocol. So these two ports, the ports that are connecting to the PTP 20 radio copper ports, they need to be configured in the same ether channel. Okay, and then the LACP will detect, okay, the standby radio, the port is disabled, so the traffic will be sent to the active radio. Okay, and on the antenna side, that's the same. You're going to use a coupler. So very important when you want to use 1+1 hot standby protection in the line protection mode, you need to make sure that the external switch will support LACP. And of course, you also need to turn on LACP on the A20S as well. Okay. And also let's talk about 1+1 hot standby with A20G. So there's multiple ways of hot standby support in A20G. So this picture here shows a redundant ODU. So you can have two ODUs. One is active and one is standby. So one of the ODU goes down, the modem will fail over to the standby ODU. So this gives you protection of the ODU. And it's good because climbing tower is always expensive, right? So let's say if something goes wrong, you don't have to climb the tower. The A20G just trigger the failover from the active ODU to the standby ODU. Okay, so that's one. But the problem with this solution is that the PTP A20G itself is not hot standby, so you still have single point of failure, right? But you can also achieve unique redundancy with A20G. With A20G, you can also achieve unique redundancy, and we support two mode, just like A20C and A20S. We support two mode. One is called the splitter mode. Obviously, with the splitter mode, you're going to have to use a optical splitter cable, or we call it white cable, right? White fiber cable. Same thing, same idea with A20S. And the trigger actually I forgot to mention with the A20S is the same. You can trigger the failover manually. For example, like from the GUI, you can force a failover to the standby. Or the other trigger to the failure to the failover is equipment failure, of course, right? Let's say one of the unit goes down or a certain RF port goes down, the failover will happen. So radio failure, right? Ethernet loss of connection, loss of carrier, Ethernet loss of carrier. So let's say if the Ethernet port goes down, obviously, we're going to trigger a failover. And also, let's say if you're using T1 or E1 on the A20G, TDM loss of carrier will also trigger failover. For T1 support, you have to use a special cable. It's kind of like a white cable for TDM, for T1 or E1 traffic. So because now we talk about this, talk about the protection trigger. So the way the failover works is that the radio actually will try to sense some alarms. If it sees alarms, then you say, okay, this radio is not functioning perfectly. I might need to trigger a failover. So it's very important when you deploy 1+1 hot standby with unique redundancy, you need to make sure that after everything is done, no alarms. After all the configuration installation is done, no alarms. Let's say if you happen to choose to have, multiple Ethernet ports turned on, but only one of the Ethernet port from each radio are being used, then you need to disable the Ethernet port that's not being used. Otherwise, there will be alarm complaining about the Ethernet port is, have a LOC, loss of carrier. And because of that, the radio will not be able to fail over properly. So very important, when everything is done with the installation configuration, no alarms, no alarms. Super important. Unit redundancy, we also support, with A20G, we also support XPIC or dual pole. So you can see you do a 2+0, 2 times 2+0. And you can see in this case, you get the A20G. Okay, so the previous slide also, we get unit redundancy and RFU redundancy, right? And same here, 2+0, 2 times 2+0, you got unit redundancy and so RFU redundancy and unit redundancy. You can see from this picture here, each of the A20G plus the RFU is configured as a 2+0. Sometimes could be a XP link, or sometimes can be just a dual pole link. So they connected with ONT, and then these two sides will be bundled together with a coupler. So on the Ethernet side, you use an optical fiber splitter or wire fiber cable. And also with A20G, we also support line protection, just like the all outdoor unit A20C and A20S. We support line protection mode. What it does is that you use the LACP from the external switch, right? So make sure that the external switch support LACP if you want to use line protection mode. Okay. Line protection mode, you support 2 times 1+0. Okay. And also line protection mode, we support 2 times 2+0. Okay, same like the split mode, but you would need an external switch to perform LACP. In terms of the software, this light protection mode was introduced in 8.7, release 8.7, but right now there's some bugs, and right now we're already in. I think you need to upgrade everything to have a stable link deployment. I suggest that you upgrade everything to 9.7, to release 9.7 for especially for 1+1 hot standby. And that's all I have for today. So I think we're going to open for questions if there's any question. Let's see if there's any question. So looks like there's no questions. Okay, I think we're done. Looks like there's no question. If you have any questions, you can send out. You can submit the question to our forum. Or the community may be looking at that and answer the question. So thank you for attending the webinar. Have a nice day.